Okay, so keep in mind that a square meter is just a giant thing compared to like the filament of a incandescent bulb, right? So we know that it's a 100-watt incandescent bulb, and it has a filament temperature and you know they give like temperatures of lights now, right? And the lower the temperature, sort of the redder the light is, and the higher the Kelvin temperature is, the bluer it is, right? But anyway, let's go for this. Let's see. So we're going to use the Stefan Boltzmann, which is emissivity times sigma times area times temperature to the fourth. And we're being told that it's a 100-watt bulb, right? So we know the power. We know the temperature. We know the emissivity, right? And then we're being asked what the area is. So let's figure this out, right? Area is going to be the power divided by the emissivity and by sigma and by the temperature to the fourth. Is that right? I think so. So 100 watts divided by 0.55 times 5.67, and this is watts, meters to the minus 2, kelvins to the minus 4. And then our temperature is 2810 kelvins to the fourth. Okay, let's see. Okay, so notice that we're going to, watts will cancel. Kelvins and kelvins will go away, and we'll end up with 1 over meters squared, which will be square meters. All right. This is not going to be a super large number. Okay, so 100 watts divided by left parenthesis 0.55 times 5.67 e minus 8 times 2810 to the fourth right parenthesis. So we're dividing by all those things, right? And that's 5.143 times 10 to the minus fifth. So it's equal to 5.14 to the minus fifth meters. Now, if this were a square, if this filament is rectangular or square, right? It would measure 7 millimeters on a side, which seems kind of big. Okay, that's interesting, huh? All right. So there's a second question, right? What is the peak black body radiation for this filament, right? So let's figure that out, right? That's going to be lambda max is 2.90 times 10 to the minus third, and that's meters Kelvin, over 2810 kelvins. So let's do that. 2.9 e minus 3 divided by 2810. That's 1.03. So 1.0 times 10 to the minus sixth. And this is in the infrared range. Okay, that would be 1,000 nanometers, right? Remember, we can see from 400 to 700. So 700 would be reddish. So the interesting thing is that the peak of this thing is well to the large wavelength end of the visible light spectrum, right? Which means, they're not efficient. This is why incandescent bulbs are being phased out. They mostly generate heat, right? This is like, would feel like a sun lamp, right? Anyway, there you go.